We are going to wrap up our discussion about the link layer as well as the Internet Protocol stack. However, at this very end, it is worth to take a very brief look at data center networks. Are they like LANs? Data center networks are used for applications like content distribution, parallel computing infrastructure provision, and cloud computing. They are networks consisting of tens to hundreds of thousands of hosts closely coupled in one location. Amazon, Google, Microsoft, and other tech giants have their own data centers for different purposes. Data centers, in that sense, are dense networks with multiple applications, each serving massive number of clients. Managing and balancing load, avoiding processing to achieve faster response, providing manageable network setup, configuring and operations of the network, and resolving networking bottlenecks are among the challenges in designing these networks. The figure shows inside of a Microsoft data center module. The end systems or hosts are the main workers in the data centers. They are commodity hardware that are called blades and are made in modular formats called pizza boxes. 20 to 40 of these pizza boxes are fit together in a rack. All of them are connected to a switch called top-of-the-rack switch or TOR. In a traditional hierarchical data center design, a number of TORs are connected to a Tier 2 switch, which in turn are connected to a Tier 1 switch in a hierarchical way. Then, these Tier 1 switches are connected to an access router. This would form a Layer 2 network or a LAN under each segment router. A load balancer, performing application layer routing, receives external client requests and directs workload within the data center. It also returns results to external clients. Therefore, a client outside the data center interacting with the hosts inside the DCN would not be aware of the complications of networking within the DCN. The traditional hierarchical design is limited in terms of throughput among the hosts. Therefore, many more advanced designs are proposed for data centers, focusing on increasing the path diversity, reliability, and redundancy to improve overall performance. One of such designs is as shown in the figure, which attempts to increase the path diversity among Tier 2 to Tier 1 switches to remove networking bottlenecks in the hierarchical design. This is active field of research. Now that you know about Layer 2 and Layer 3 networks, broadcast domains, VLANs, routing and forwarding, and software-defined networking, you may find this a great direction if you want to further your learning about networks.